Figure 2 shows a sketch of part of the curve C with equation y is equal to a third x squared minus 2 root x plus 3, where x is greater than or equal to 0. Point P lies on C and has an x coordinate of 4. So let's put that on our diagram. The x coordinate for this point is 4. And then we're trying to show that the equation of L is this: 13x minus 6y minus 26 is equal to 0. So that's the equation of the tangent. So whenever you have a tangent, or whenever you're trying to work out a tangent equation, you want to think of differentiating. So let's first rewrite our equation. A third x squared, keep that as is. I'll change the 2 root x to 2x to the half, so it's easier to differentiate. So differentiate this, multiply by the power, reduce the power by 1. 2 times a half is just 1. Reduce the power by 1, and 3 differentiates to make 0. And we're trying to work out the gradient at point P. The gradient of the tangent is the same as the gradient of the curve at point P. So then what we can do is we can put in an x coordinate of 4 into our gradient function. That will tell us the gradient of the curve at P, and therefore will tell us the gradient of the tangent at P. So put in 4 into this gradient function, and that gives us 13 over 6. Okay, so we have our gradient. Gradient is equal to 13 over 6. We have our x coordinate for point P. I'll call that x1. That's equal to 4. We now need to work out our y coordinate. So to work out our y coordinate, we just have to put in our x coordinate of 4 into this equation here. So put in 4, y is equal to a third of 4 squared minus 2 root 4 plus 3, and that gives us 13 over 3. So coordinate of P is 4, 13 over 3. And then we can use the equation of a tangent, or equation of a straight line rather. Y minus y1 is equal to gradient times x minus x1. Put in our y1. y1 is 13 over 3. Our gradient is 13 over 6, and our x coordinate is 4. So now we want to simplify this. To do so, I'll multiply the entire thing by 6 to get rid of the fractions. So this then becomes 6y. The 13 over 3 times by 6 becomes 26. So multiply this by 6, we get 13. And now I'm going to multiply that 13 by this bracket here. So it'll be 13x minus 13 times 4, which is 52. And then finally, we can bring everything to the right. So subtract, take away the 6y, add the 26, minus 52 plus 26 would be minus 26. So that's part A. For part B, we're told first of all, that the region R, shown shaded in figure 2, is bounded by the y-axis, the curve C, the line L, and the x-axis. And it's shaded here. So we can see what region R is. We're trying to work out that area. So we can do that by integrating the curve between x is equal to 0 and x is equal to 4. That will give us this whole area here, including this unwanted triangle there. So then we can work out the area of that triangle, take it away from the integral, and that will give us just region R, just the shaded region. So our integral, we're integrating the curve between, so the x-coordinates, the bounds for our integral would be 0 and 4. And this is what we're integrating. So that will be third x squared minus 2, again write it as x to the power of a half, makes it easier to integrate, and the limits would be 0 and 4. So raise the power by 1, divide by the new power. So 2 divided by 3 over 2 would be 4 over 3, and the 3 integrates to make 3x. We're putting in 4 and 0. So when we put in 0 into that, we'll just get 0. So the answer will just be what we get when we put in 4. And that would be 76 over 9. Okay, so now we need to work out the area of the triangle. We know the equation of the line, L is this here. So to work out the area of the triangle, we'd have to do half base times height. So we'd want to know what this coordinate here is to work out what the base is. This coordinate here will be when the line crosses the x-axis. So that will be when y is equal to 0. So we're looking at our equation of our line, which is this. We're setting y to be equal to 0. That will be when we work out our x-intercept. If y is equal to 0, 13x minus 26 is 0, and that gives us x is 2 when we rearrange that. So this coordinate here is 2, meaning the base of our triangle is also 2, and the height of our triangle, so from here to the bottom, that will be the y coordinate of this point, 13 over 3. So base is 2, height is 13 over 3. So then the area of our triangle, which is half base times height, would just be 13 over 3. And again, this here is the area under the curve. And then we take the two things away. 76 over 9, the area under the curve, minus 13 over 3, which gives us 37 over 9, which would be our final answer.